Linux is not an operating system, it's a kernel. When combined with the other software, it creates a complete operating system such as Ubuntu, Fedora, Debian, etc., which are referred to as Linux distributions. These distributions come up with different software and interfaces, making each a unique operating system. So, what is kernel then? Kernel manages hardware resources like CPU, memory, and storage, and allows software, which means applications, to communicate with the hardware. In this video, we'll explore the basics of Linux, how is it differ from Unix, and why people choose Linux over popular operating systems like Windows and Mac OS. Linux is built by taking Unix operating system as an example. Linux builds on Unix principles, which was built on 1970s, such as multitasking, multi-user environment, security, portability, and networking, but with more flexibility and frequent updates. Linux distributions include Ubuntu are lightweight and can run efficiently on older or less powerful hardware compared to Windows and Mac OS. For example, Windows installation size is around 20 GB. After installation, Windows may require 30 GB or more. Ubuntu requires only 2 to 4 GB. After installation, it might require 20 GB more. Linux is open source and free. It is more secure. It efficiently uses CPU, RAM, and storage. Its fast nature makes it a top choice for many professionals. Learning Linux gives you an advantage in today's tech world because it's widely used for managing cloud servers and daily DevOps tasks. Okay, first we'll learn Linux basic yet most useful commands. Now you might be confused, what is this? This is an office laptop. Anyways, this is an Ubuntu terminal downloaded from Microsoft Store. So Gautam, here is a username, and INHY over here is a machine name, and this dollar represents I'm a normal user. Hash represents a root user. You can switch to the root user by using su dash command. Now hash represents I'm a root user. You can switch back to your user by using su dash. In Linux, everything is a file, even the commands that you are going to learn today. A file system is a tree data structure that any operating system uses to store files on a disk. File system makes it easy for you and your computer to find, read, and write and manage files efficiently. First, let us look basic folders and their functions. First is root folder. This is a main folder that holds everything on your Linux system. Next is bin. This folder contains binaries of most used Linux commands like ls, rm, cp, etc. Next is sbin. Similar to bin, but it holds system binaries, which are essential commands used by system administrator. You will go here for the commands that require root permissions. Next is lib. It stores libraries needed to run programs. For example, programs in bin and sbin depend upon the files stored in lib to work. Next is etc. This folder holds configuration files of your system. For example, network settings or which service starts on boot is saved in /etc. Next is var. This holds files that change frequently, like logs or emails. For example, var log stores system log files to track errors or issues. Next is temp. Temporary files go here. For example, when a program needs to store data just for a short period of time, it uses /temp. Next is /proc. It holds real-time system information. For example, you can see your CPU current status in /proc folder. Next is /boot folder. It holds files needed for booting the system. For example, Linux kernel and other startup files are stored here. Next is /mount, a temporary place to mount external storage devices. For example, you can manually attach a network drive here. Next is /dev, which holds special files of your computer's hardware like keyboard, mouse, and drivers. These files allow the system to interact with the hardware. Next is /user. It contains a software that is a part of your operating system or common applications that come pre-installed. Next is /opt. It holds additional software that you manually install, which is not included with operating system by default. This can be optional or third-party applications. For example, if you install a game or a software package that is not a part of your operating system, it might be located in opt folder. Okay, now you understood all the folders in the Linux file system. Before learning the first command, let us learn even more basic commands. First is pwd. It shows present working directory. Next is uname. It shows the name of the kernel. uname-r shows the version of the kernel. As I am using a Ubuntu terminal, and that's why this Microsoft thing came up. To clear the terminal, you can use Ctrl-L or clear command. Next is who am I. It shows currently logged in username. Next is date, which shows date and time. The first command that we are going to learn today is ls. This command is used to list the files and directories in the current folder. Nice and clean. But we didn't got much information, right? Let's level up with ls-l. We ask for more details: file permission, owner information, size, and even the last time it was modified. Next, let's bring out the hidden treasures with ls-a. This command will show you even the hidden files. Those start with a dot. All these dot files are now visible. These are usually a system or a configuration files. Want to look inside every folder in your current directory all at once? Then use ls-r for recursive listing. It shows you everything in your directory and all the subdirectories. Now I'm inside the groupadd folder. As using this command in the home directory, the result will be humongous. Inside the groupadd folder, I have bin, package and src folders. If I use ls-R in this folder, the result would be something like this. There is nothing inside bin folder, there is nothing in the package folder, but in source folder I have few files and one folder named pel. Inside the pel folder I have hello and pel.go files. It lists each folder and what's inside them. This is a neat trick when you want to see the bigger picture. While using ls-l, if you want to convert this 272404, which is the size of all the files, to megabytes or kilobytes or gigabytes, then you have to use ls-lh. Look, now this is converted into 267 megabytes. You might have seen in many places people using ls-ltr instead of simple ls-l. This command sorts files and folders according to the time they were modified. Newest files at the bottom. The T is for time and R is for reverse order. It's perfect when you want to see the most recent files. The latest files are now neatly listed at the bottom. Perfect for keeping track of what you have just worked on. If you simply use ls-lt, the newest files are at the top now. Second command is cd, which means change directory. Its job is to simply take you from one folder to another. If you want to move to groupadd folder, we have to use cd groupadd. Will be in this folder. cd tilde symbol takes you to home directory, cd / takes you to root directory. Using cd dot, you will stay in the folder itself. Using cd dot dot, you will navigate to the parents directory. I want to explain something more here. When you use cd dot dot, you are moving up to the parents folder. Every folder has a links that connect to its parent, and these are called hard links. You can see these links with ls-l. Check the second column. You will notice the number there. That number tells you how many hard links point to that folder or a file. Every folder and a file in a Linux is tied to its data on a disk through hard links. When you create a file, Linux keeps a count of how many hard links pointed to it. Here 2 for this folder means there are 2 hard links. One for the folder itself and another for the parent folder. Here for this groupadd folder, which has 2 more folders and a file inside it, the number of hard links are 4. One for the folder itself and another for the parent folder, and each subdirectory contains a link back to the parent folder. So when you use cd dot or cd dot dot, you are following that link back. So every time you navigate to directories, you are working with these links behind the scenes. You can go to that bin folder using cd bin, or from the home directory itself you can directly navigate to bin using go park and /bin. Next command is touch. Using touch we can create a files. Let's create a file name called file.txt using touch. Next command is make directory, using which we can create a folder. Let's create a folder called kgf and move into that folder. Next command is echo, which is used to print some text on the screen. Now let's create a file name called kgf1.txt and add some text to the file. That greater than symbol over here is called output redirection, which is used to print that kgf is super hit text in that kgf.txt file. Let us see what is in that kgf.txt file. Next command is cat, which is used to print the contents of the file on the screen. If you want to add another line to this kgf.txt, then you have to use double greater than symbol after the text, which is used to append this text to the previously existing contents of that file. Next is man command, which is used to display the manual pages or documentation for other commands or programs installed on the system. It provides a detailed description, usage options, and examples of how to use the command. You can use Q to quit. Next is cp command, which is used to copy files and directories from one location to another. It is one of the most commonly used commands for file management. Let us create one file and copy its contents to another file in another location. Now I am going to copy the contents of kgf.txt to already created file.txt in the home directory. Instead of using a tilde symbol before the file.txt I just normally used, so a new file.txt was created and the contents of that kgf.txt was copied to the file.txt in the current folder itself. mv command is used to move the files from one location to another location and removes that file from the source location, and people also use this command to rename the files. Next command is rm, which is going to remove the files. If you want to remove a directory, then you must specify rm-r. Next command is sudo, which means super user do. It allows a user to execute a command as a root or any other user. This is essential for performing administrative tasks. It is used while installing a package or editing a system file or restarting a service or removing some protected file. Next is find command, which is used to search for files and directories within the directory specified. For suppose if I want to search for pel.go inside this goprac, src and pel folders, I don't know where it actually resides. If you have a rough idea in which folder the pel.go file is present, the shell will search in that folder only. I want to search in the entire home directory. For that I use find home symbol and dash name pel.go. If you forget to put dash name over here like ls-r capital R, the find command is going to give you all the files and folders recursively and pel.go file. The result is so huge, right? Using less command, we can view the output in a scrollable manner. For that, I'll repeat the same command. Besides that, I'll use a pipe symbol and less. Pipe over here is going to give you the output of this command as input to the less command. Like ls-R, you can view all the files recursively, right, in the home directory. You can use Q to quit. Sometimes you might not know the exact name of the file. If you remember the extension, we can use the find command to search all those types of files. For suppose if you want to search all the go files in the home directory, I'll just type dash name star.go, which means the file name should end with .go. Suppose if you want to get all the directories in the home directory, then you have to use dash type d, which means for directories. So using find command, we just now find the pel.go file location, right? For suppose if you want to delete that pel.go file with this command, then you have to use dash type f dash delete. Simple. Next, history command in Linux displays the previously executed commands in your terminal. This can be pretty useful for recalling the past commands, for re-executing them. You can re-execute a command you want from the history using exclamation mark followed by the command number. For suppose if you want to execute a command with a number 1333, you have to use exclamation mark 1333 and the command will be executed. Another way to search through your history interactively is by using a reverse search. Ctrl R and start typing the part of a command. It will search backward through your history and show you the most recent match. If that was not a correct match, keep on pressing Ctrl R till you get the correct match. Next commands are head and tail, which are used to display beginning and end of the files. By default, they are going to display first and last 10 lines. To demonstrate these commands, I wanted to use var log syslog as it contains a lot of information about system logs. If I use head var log syslog, it is going to give me first 10 lines. If I only want first 5 lines, then I use head dash n 5 var log system log. Same goes with tail as well. Next commands are on user, group and permission management. Now let's create a user and a group and attach user to the group. We can create a user in Linux using adduser command. To execute this, we need admin privileges. So we use sudo to run this command. Sudo adduser kgf. Hit enter and enter the new password. Now kgf user will be created. You can switch to the newly created kgf user using su-kgf. You can switch back to Gautam user using su-Gautam. Now let's create a group using groupadd command. You will need admin privileges here as well to run this command. Sudo groupadd narachi. Now narachi group will be created. You can view all the groups in this Linux system in /etc group file. And all the users in etc password file. Now let's add kgf user to narachi group using usermod command. Sudo usermod -g narachi kgf. Now kgf user will be added to narachi group. Now let's verify whether the user was added to the group or not. Using groups username. This displays in which groups the user was present. If I type groups Gautam, the Gautam user was present in these many groups. Have you observed one thing? Gautam user was present in Gautam group, but kgf user was not present in the kgf group. Because the usage of small g over here. To avoid removing a user from the previously existing groups, you have to use -a flag. This ensures to add a group to the user instead of removing from every group. If you want to add a user to multiple groups at a time, then you have to use -G flag. When using ls-l command, the fourth and fifth columns of the output are the user who owns the file or a folder and a group who owns the file or a folder. Can we change the owners of the file or a folder? Yes, this is where chown command comes in. Now let's again create the kgf user and narachi group and add kgf user to the narachi group and make them the owners of the groupadd folder. Now first I'll create a narachi group using groupadd command, sudo groupadd narachi. Instead of creating the user with a user add command and then attaching to the group using usermod, I will combine both steps in a single command. Sudo useradd -g narachi kgf. This will create a kgf user and add it to the narachi group at the same time. Now I'll use chown to change the owners of the groupadd folder. Sudo chown kgf narachi groupadd. Now the user kgf and the narachi group will be the owners of the groupadd folder. If you want to change the user of the groupadd folder, keeping group unchanged, then you have to simply specify the username. This will change the user and doesn't change the group. If you want to change the group without changing the user, then you have to put :group name. This will change the group name. Now what is the use of changing the owners of the file or a folder? You will understand. When using ls-l command, the first column is for permissions, for folder the first character is D and for file it is dash. Next 3 characters are the permissions for the user who owns the file. Next 3 characters are the permissions for the group. And last 3 characters are the permissions for others. R means read, W means write and X means execute. Can we change the permissions for the user or a group? Yes, using chmod command we can do that. There are 3 types to change the permissions on a file or a folder. Let us take this groupadd folder as an example for this demo. To add permissions you have to use plus, to remove permissions you have to use minus. For suppose if you want to add an execute permission for the user kgf, then you have to write sudo chmod u+x groupadd. This means you are adding an execute permission to the user kgf. If you want to remove the write permission for the user, then you have to use u-w, which removes a write permissions to the user. If you want to add a write permission to the group, then you have to write g plus w. Or suppose if you want to remove a read permission for the other users, then you have to write o minus r. In this type, we can't add multiple permissions to user or group or other users. Now let's see type 2. If I want to give read and execute permission for KGF user on goprack folder, I'll simply write u equal to rx, which adds read and execute permissions for user KGF. If I want to give only write permission for group, then I simply write g equal to w. If I want to give all the read, write and execute permission for other users, I'll simply write o equal to rwx. This adds all permissions to other users. Now let's see type 3. With this type, we can assign all the permissions at a time to all users, groups and others. This type is most used. Here we used numbers to assign permissions. 0 means no permissions, 1 for execute, 2 for write and 4 for read. For suppose if I write sudo chmod 653 and goprack folder, let's break down the numbers over here. The first number is the permission for user, and second number is the permissions for group, and third number is the permission for other users. 6 means, just now I said 1 for execute, 2 for write and 4 for read. 6 means 4 plus 2, read and write permission for user KGF on goprack folder. 5 means read and execute permissions, which is 4 plus 1 for Narachi group on goprack folder. 3 means write and execute 2 plus 1 for other users on goprack folder. Let's see the result of this command by typing ls-l. Now we know some commands in Linux. We are not beginners anymore. Now it's time for searching and filtering. The first command that we are going to look is grep. When you want to search for a specific text within files, whether you are looking through log files, script files or any text-based files, grep helps you find specific patterns of a text super quickly. For suppose in this ls-l command output, if I want to filter out only this go line, I will use ls-l pipe and grep go. We have already seen pipe is going to give the output of first command as an input to the second command. Here the output of ls-l command serve as input to the grep command. And here we are asking to search for go. If I hit enter, I only see that go line. Okay, as Gautam also contains go within the name, grep is displaying it when I search for go. But if we want only the lines that contain go exactly, what we have to do? If you have any idea of regular expressions, by adding the dollar symbol at the end, we specify the line should end with go. Now only the lines that contain go will be displayed, not Gautam. We can also use grep to search within the text without using the pipe command. We have just now seen var log, system log contain all the system log information. If I want to display what is in the file, I have to use cat var log syslog. Here we got bunch of information. If I want to filter out all the lines that contain this word starting, I'll use grep starting var log syslog. Okay, grep is case sensitive. If you want to ignore case, just put -i flag before it. We can also use grep to search for text within all the files in a directory and its subdirectories recursively using -r flag before the search text. Grep searched in varlog, syslog, varlog, this installer and varlog journal. Basically it was searching in all the files in this directory. Just now we saw in the ls-l output, using grep we can filter out the lines that has a specific text. What if you need some 4th or 5th fields in the filtered lines? Here we use awk command. Awk command will scan the file line by line and breaks each line into fields and performs some actions on each field. For suppose if I want 2nd and 6th fields in the ls-l output, I use ls-l pipe awk print $2 $6. This gives me 2nd and 6th fields. You have to put dollar for the field you want. Wait, how does this awk knew that this is 2nd and this is 3rd and this is 6th fields? By default, awk uses a space as delimiter. It separates words by spaces and selects second word, sixth word, fifth word, whatever the number specified. We can even change this behavior. Now I want dash to be treated as delimiter instead of space. If I repeat the same command and use -f, known as field separator, I can mention here any symbol. Now I'll put dash. Now awk treats dash as delimiter and separate words by dashes. Up to here this is first word, this is second word, from here to here this is third word. Now I want to filter the lines that contain October and print some fourth or fifth fields in it. For that I use /October/ before print. This searches for October in the ls-l output and prints fourth and fifth fields. Okay, we understood what is awk. But what is this print? This is a bash script. Awk accepts bash script. I'll explain bash after this Linux tutorial. But before that, let's look what is cut command. Cut command is just like an awk command used to filter the specific fields from the lines in a file. But this is simple and fast tool compared to awk. Awk can do more complex processing such as pattern matching, arithmetic operations, filtering rows and manipulating data. Anyways, now I am in this kgf folder. If I want fourth character from this kgf1.txt file, then I use cut -b for kgf1.txt. -b here is bytes. We can even use -c as well for characters. kgf1.txt is a source file, which means we are asking to get the fourth character from this kgf1.txt file. But if I want some fourth and seventh characters from this kgf1.txt file, I can specify 4,7 here. It is going to give me fourth and seventh characters in this kgf1.txt file. If I want second word from the file, I use -f2. Along with that, I will use -d, which means delimiter. Over here we can put any delimiter, just like awk command. For now I'll put space. Now the meaning of this command is get the second word from this kgf1.txt file treating space as a delimiter. Now let's understand the difference between cut and awk and when to use. Cut is simple tool. If we want some fourth and fifth words from the file, then we have to use cut. For suppose, if I want to print lines only when the length of the second word is greater than 2. In this type of scenarios, we have to use awk command. Finally, in this ls-l output, if I want to filter out the fifth word using cut command, I'll use cut -d space as delimiter -f and 5. But the result is so weird, right? Cut command over here doesn't behave as awk command over here. This is because we have specified space as delimiter, but between fourth and fifth fields there are many spaces. Here in 10020, between Gautam and this field there is only one space, and that's why this was printed. Next is set command, which is used to replace one word in a file with any word specified. Now I am in this kgf folder. If I want to replace this super word in this kgf.txt file with excellent, I will use sed s/super/excellent and name of the file. Here s is used to search the word super, and set command replaces all the occurrences of super with excellent, and slash over here is a delimiter, works fine with any other symbols as well. If I use colon instead of slash, this also works exactly as slash. We can use any symbols here as delimiters. But doing like this, it doesn't replace the contents of the file. To do that, we have to put -i here, which replaces all the occurrences of super with excellent. If I put /i at the end, set command will even ignore the case. If I want to replace excellent with capital super, I will use the same command but attach /i at the end. Here I have used space as delimiter. Don't forget to put the delimiter that you have chosen at the end. Okay, next it's time for basic networking commands in Linux. First command is curl, which is used to fetch the data from URLs. To test this, I use curl and my GitHub link as a URL. It is going to give me the page. Similar command is wget. If I use this wget command with my GitHub URL, the page will now be downloaded into my workspace. Next command is ping, which is used to test the network connectivity between the two devices. This command helps us to check if a website or a server is reachable from our machine. Next command is ifconfig. It helps you to check the status of your network interfaces. When you run the ifconfig command, you will see a bunch of information, and I will give an overview of this bunch of information. Each of these represents a different network interfaces on your system, such as Ethernet connections, virtual networks created by Docker, and the loopback interface used for internal communication. Let's leave first 4, as these are bridge interfaces used by Docker for networking between containers. They let containers communicate with host machine and each other. ETH0 represents the first Ethernet network interface on your computer. If you have a multiple network interfaces, the first one is labeled with ETH0 and second one as ETH1 and so on. This interface is used for wide network connections. INET is the IP address assigned to that network interface. INET6 is IPv6 address. Ether is the MAC address of your Ethernet interface. RxTX packets means it shows how much data has been received and sent over this interface, which is pretty helpful for monitoring networking activity. Finally, the LO interface stands for loopback interface, which is a special network interface that your computer uses to communicate with itself. It's a virtual network interface that allows your computer to send and receive data to itself. It acts like a bridge, enabling internal communication without need of any external network. It's primarily used for testing and development, enabling applications to send and receive data internally without using any external network. The IP address here is always 127.0.0.1. It is also known as localhost. RxTX packets here also refers to how much data has been sent and received through this interface, but only internally on your system. You will see a different IP address on an external side compared to the one shown in your ifconfig output. The IP address displayed in your ifconfig output is a private IP address assigned to your device within your local network. This address is not visible on the internet and is used for internal communication within your network. When you check the IP address on an external website, it shows your public IP address. This is the address assigned to your network by your ISP, and it is used for communication over the internet. Most routers use network address translation to allow multiple devices in your local network to share a single public IP address. This means all the devices that are connected to your router will have their own unique local IP addresses, but share one public IP address when accessing the internet. You can see your public IP address using curl ifconfig.me. Now the IP address shown here is similar to that one shown in external site. Now let's close this session with nslookup command. This command is used to give the IP address for the domain name specified. To test this command, I use nslookup google.com. It gave me the IP address of Google. Okay, now that we have explored the basics of Linux, in the next video we will dive into Bash, the powerful shell that helps you interact with your Linux more efficiently. Subscribe for more cloud and DevOps content. See you in the next video.